here we're going to look at story problems where there's two things we don't know. So we have a table and a bench cost $750 combined. Table and a bench. Then they say the cost of the table is 2 times the cost of the bench. What do they each cost? So if we come up with variables, and you can pick X and Y, but it's very often helpful to pick variables that make sense to the situation. That way at the end you won't mix up, hey, which one was X, which one was Y. If we make T table and B a bench, or the price of the bench and the price of the table, it'll be a little harder to mix up which one's which. Okay, and so whenever they tell us information, they should be, if we have two unknowns, telling us two equations somehow. So if we read this, a table and a bench cost $750 combined. So what operation does that make us think of? Well, it's the total of their prices. So total is addition. So I know the table plus the cost of the bench should equal $750. So table price plus bench price. So maybe one's 700, maybe one's 50, maybe one is 600, maybe one's 150. We're trying to figure out, but we know the total is 750. Okay, so if we read the other sentence we haven't used yet, it says the cost of the table is 2 times the cost of the bench. So I know I'm going to do something multiplied by 2. But then sometimes you start questioning, is it 2 times B or 2 times T? If you read the sentence, sometimes you can tell it says 2 times the cost of the bench, so 2 times B. But another thing that's helpful is think about when you read that sentence, which one costs more? The cost of the table is 2 times the cost of the bench. So that sounds like the table is the more expensive one. So if the table is the more expensive one, think you'd have to multiply 2 by the cheaper one to get it to equal the price of the more expensive one. So whether or not you're adding or subtracting or multiplying, you can always think of that too. It makes sense to do 2 times a smaller number gives you a bigger number. So another way to sort out. All right, now that we have 2 equations, we can solve them. Sometimes they might be set up better for elimination. This one looks like it's set up great for substitution because we notice here they're telling us that T is equal to 2B. Meaning wherever there's a T, I could put 2B and it would be the same thing. So in the other equation, where there used to be a T, so T plus B equals 750, instead of putting T, I'm going to put something that's the same as T. Well, I know T is the same as 2B from the other equation. That's what equals means, right? They're the same as each other. They're equivalent values. They're interchangeable. And so now notice I have an equation I can solve for the price of the bench. So 2B plus B gives you 3B equals 750, and then divide both sides by 3. So it looks like the bench costs $250. And then I can use that to figure out what the table was. I can either put it here and say, well, 250 plus 500 would give me 750. But let's check it in the other one also. The table's twice as much as the bench. So 2 times 250, if we plug that back in there, gives us a table is $500. So it works in both equations. They add to 750, and one of them is twice as much as the other one.